Hello my precious friends, I really hope that you're doing great. Welcome to today's class. It's our 16th lesson on a given Form 4 mathematics topic called differentiation. So we are looking at our example 23, which is a past Kcse question tested in 2018, paper 1, question number 19. It reads that the distance covered by a moving particle through point O is given by the equation S is equals to t cubed minus 15t squared plus 63t minus 10. Find part A of the question, the distance covered when t is equals to 2 seconds. Now remember, we are already given the equation for the displacement s, which is simply the distance. So they want us to find the value of s when t is equals to 2 seconds. So of course we are simply going to substitute in the equation for s, which is equals to t cubed, then of course minus 15t squared, then plus 63t, then minus 10. So we simply substitute when t is equals to 2. So s when t is equals to 2 will be equal to, so we are going to have 2 cubed, then of course minus 15 into 2 squared, then plus 63 into 2, then of course minus 10. So this will be equal to 2 cubed, of course that will be 8, then minus 15 into 2 squared, that is 4, then of course plus 63 into 2, then minus 10. So this will be equal to 8 minus, you take 15 multiplied by 4, that will give you 60, then 63 multiplied by 2, that will give us 126, then of course minus 10. So you feed that on the calculator, you're going to get 64 meters. Therefore, this is the displacement of the particle, or the distance covered by the particle when t is equals to 2 seconds. Then we look at part B of the question, whereby we are told to find the distance covered during the 3rd second. Now, a point to note here is that during the 3rd second simply means you take the second up to the 3rd second. Remember, the first second, during the first second, simply means the period from 0 seconds up to 1 second. Then during the second second means the period from the first second up to the 2nd second. Then during the 3rd second, means the period from the 2nd second up to the 3rd second. Therefore, the distance covered during the 3rd second simply means we take the distance when t is equals to 3, then we subtract the distance when t is equals to 2 seconds. So that is what we mean by the distance covered during the 3rd second. You take s when t is equals to 3, then you subtract the distance when s is equals to 2. If it was the distance covered during the 2nd second, you will have taken the distance between when s is, that is s when t is equals to 2, then minus s when t is equals to 1. Then the distance covered during the 1st second means you take s when t is equals to 1 minus s when t is equals to 0. So that's a very essential point to note whenever you're interpreting that one. Therefore, we are simply going to take, we first of all find s when t is equals to 3. So this will be equal to, of course, s was t cubed, then minus 15t squared, then plus 63t, then of course minus 10. So we are simply going to substitute t, that is s is equals to 3 in our equation. So we're gonna have the following. So s will be equal to, so t is equals to 3, so this will be 3, then of course cubed, then minus 15 into 3 squared, then of course plus 63 into 3, then of course minus 10. So this will give us 3 power 3, that is 27, then minus 15 into 3 squared, that is 9, then of course plus 63 multiplied by 3, then of course minus 10. So this is going to simplify into 27, then minus, you take 15 multiplied by 9, your calculator will give you 135. Then of course plus, you take 63 multiplied by 3, your calculator will give you 189. Then minus 10, of course this one, you feed this, 27 minus 135, then plus 189 minus 10, your calculator will give you 71 meters. Then you also get S whenever T is equals to 2. So this will be equal to, so of course we're going to have 2 cubed, because now our T is 2. Then of course minus 15 into 2 squared. Then of course plus 63 into 2. Then of course minus 10. So this is going to simplify into the following. 2 cubed of course will be 8 minus 15. 2 squared, that is 4. Then plus 63 into 2. Then of course minus 10. So this will be equal to 8 minus 15 multiplied by 4. You'll still get 60. Then 63 multiplied by 2. You'll get 126. Then minus 10. You feed this on the calculator. Your calculator will give you 64 meters. Therefore, the distance covered during the third second, S during the third second, S during the third second will be equal to S when T is equals to 3, then minus S when T is equals to 2. So this is going to give us the following. So this is what we are going to get. So we're going to have S being equal to, so S during the third second. So this is during the third second will be equal to S when T is equals to 3. We already have it here. This was when T was equals to 3. We got 71 meters. So this is 71 meters minus S when T is equals to 2 seconds. We got it as 64. So this was 64 meters. So you take 71 minus 64. Your calculator will give you 7 meters. So that is the distance covered during the third second. Then we move to part C of the question, whereby we are being told that to calculate or to find the time when the particle is momentarily at rest. Remember we said that when the particle is at rest, it simply means that the velocity of such a particle is 0. So we said that at rest, since there is no change in displacement, V, which is ds over dt, will always be equal to 0. Remember, at rest, the particle is not covering any distance, therefore the displacement is 0. You take 0 over dt, the final answer will be 0. Therefore, clearly we need the formula for the velocity. So remember, we already have an equation for S. S was given by t cubed. Our S was t cubed, then minus 15t squared, minus 15t squared, then plus 63t, plus 63t, then minus 10, minus 10. That was our S. T cubed minus 15t squared, then plus 63t minus 10. So to get our velocity, so this will be equal to, so our V will be equal to d over dt into S. Our S is t cubed minus 15t squared, then plus 63t, then of course minus 10. So of course we're going to differentiate our equation so that we can get the V. Then at rest we are saying that this one is equals to 0. So clearly our V will be equal to, I differentiate this part, this will give me 3t power 2. Then of course minus this one, I differentiate this, of course this will multiply by 15, which will give me 15 by 2, that is 30. Then of course t to the power of 1, that is 2 minus 1, you will remain with 1. Then plus, this is power 1, of course 1 times 63, I'll get 63. Then t power 0. A number to the power of 0 is 1. Then of course this is t power 0. When you differentiate, the whole of this term will disintegrate to 0. So of course this should be equal to 0. So V is equals to 3t squared, then minus 30t, then of course plus 63, which is equal to 0. So clearly these are quadratic. Remember, we are equating to 0 because we are told that when the particle is at rest, and we are saying that at rest the velocity of the particle will always be equal to 0. So clearly this is a quadratic, but we can reduce it to make our work easier. So 3t squared minus 30t then plus 63 is equals to 0. The common term which can divide through all the given terms, of course, will be 3. So I'm going to divide through by 3. So over 3 over 3 over 3 over 3. So this will give me t squared because the 3 will cancel out. Then of course minus 10t, the 3 into 30, that is 10, 10 times. Then of course plus 3 here 1, 3 here 2, 3 here 1. Then plus 21 is equals to 0. So these are quadratic in the form ax squared, then plus bx, then of course plus c is equals to 0. Such that our value of a will be the coefficient of t squared, which clearly will be 1. Our value of b will be negative 10. Then the value of c will be 21. So to solve for t, we need the product, which is ac. So this will be 1 multiplied by 21, which will be 21. Then the sum is the value of b, which is equals to negative 10. Then we check the common factors here. Of course, by 7, I can start with either 7 or 3. By 3, this will be 7. Then of course by 7, that will be 1. So our two factors will be 3 and 7. So we are having 3 and 7. So our two factors will be 3 and 7. So I'm having 3 and 7. 3 and 7. So for me to get a product of 21, I need 3 and 7. A sum of negative 10. I'll introduce a negative here and a negative. So that negative 3 minus 7, I'll get negative 10. Negative 3 times negative 7, I'll get a positive 21. So I pick my original equation, which was t squared. So I'll have t squared, then plus, I pick my factors, negative 3 minus 7. I don't need a comma here. So negative 3 minus 7, then of course t. I continue with my equation, so plus 21. Plus 21 is equals to 0. So this is t squared minus 3t minus 7t, then plus 21 is equals to 0. So I factor out t, so this is t into t minus 3. Then I factor out 7, so minus 7, this will be t minus 3 is equals to 0. So clearly I'll pick this one and this. So I'll have t minus 7, then of course into t minus 3. I pick one of the other brackets is equals to 0. So this one means either t minus 7 is equals to 0, which clearly will give us t being equal to 7, or the other possibility is t minus 3 being equal to 0. Therefore, so this one simply means that the t, our t will be equal to a positive 3. Therefore, our values of t will be equal to 7 and 3. Therefore, t is equals to 7 seconds. And the other value of t is also equal to 3 seconds. 3 seconds. So that is the time when the particle was momentarily at rest. It was at rest when t was 7 seconds. It was also at rest when t was equals to 3 seconds. So it means that it went to a state of rest in 2 instances, when t is 7 and when t is equals to 3. Then we look at part D of the question, whereby we are told to find the acceleration when t is equals to 5. Of course, you can't get acceleration unless you have the velocity, because you know that acceleration is dv over dt. So this one simply means that our a will be equal to d over dt into the equation for velocity. We already have it here. It is 3t squared, 3t squared, then minus 30t, then of course plus 63. So to get a, we are simply going to differentiate, since we are dividing with the dt. So we differentiate this equation. The 2 will pre-multiply the coefficient, so we'll have 3 by 2, then t power 2 minus 1, then this is power 1, this pre-multiplies the coefficient, minus 30 multiplied by 1, t power 1 minus 1. Then these are constant, so power 0. So you're going to have 63 times 0, t power 0 minus 1. So our a will be equal to 3 by 2, that is 6, t power 1, that is 2 minus 1, then minus 30 t power 0. A number to the power of 0, of course, is 1. So this is 6t, then of course minus 30 by 1, which will give us a being equal to 6t, then minus 30. So this is an equation for the velocity, that is the acceleration of the particle at any given time t. But they want the acceleration when t is 5. So a, when t is equals to 5, will be equal to 6 into 5, then of course minus 30. So 6 by 5, that is 30, minus 30. So it means that a will be equal to 0 meters per second squared. Therefore, it means that the acceleration of the particle when t is 5 is 0 meters per second squared. It simply means that at this particular point, the particle is having the maximum possible speed or the maximum possible velocity. So at this point, v is maximum, or you can also say the speed of the particle is actually maximum at v, that is at a max. It simply means that the velocity of that is at v max, or at the speed maximum, the acceleration of the particle will always be equal to 0, since there will be no change in velocity. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.